Welcome, grade 10. We're going to look at some questions based on probability. And the first one comes from the Eastern Cape, November 2019. So what I suggest you do with these questions is that you look at the question, you pause the recording, and you first try. So the first question says, a letter is chosen at random from the word algebra. So what is the probability? So the moment that it's probability, you have to write it over the total. So the probability that it's going to be the letter A. So with algebra, let's see. How many options would there be for an A? There's one, and there's another one. That will be 2, so that you always, with probability, as I say, you look at how many are there divided by the total. How many letters are there? 1, 2, 3, 4, 5, 6, 7. So it's 2 over 7. And you can either write it like that, keep it as a fraction, or you can write it as a decimal, doesn't matter. A consonant. Let's see the probability of a consonant. How many consonants do you see here? Well, there's a L, a G, a B, a R. So there are 4. And how many letters in total? 7. Again, you can either keep it like that or you can write it as a decimal. The next question is going to be a Venn diagram in a class of 30 learners. So I'm going to start off making that my 30. The following information is given. There are 5 learners that are right-handed. So now you can decide which one you want to make your right-handed. So I'm just going to make this one my right-handed. 5 learners are right-handed, so I'm going to make that one 5. It means this whole circle will be 5. 12 learners play soccer, so we only have right-handed and soccer. In grade 10, you will only have 2 circles. In grade 11, they include a 3rd circle. So 12 learners play soccer, so I'm going to make this one my soccer. And in total, there will be 12 learners who play soccer. Then they say 3 learners play soccer and are right-handed. So you first read everything. So if it's play soccer and right-handed, so it means it overlaps. So this will be 3. They don't say anything else. So now you start off here by getting right-handed only will always be this number, the 5, minus the one that overlaps. So it's 5 minus 3. So 2 will be only right-handed. So only right-handed will be 2. For this one, those who only play soccer will be the 12 minus the 3. And 12 minus 3 is 9. So 9 will be playing soccer only. Right. So now let's see what will be here on the outside. Because I mean, if there are 30 pupils, and 5 are right-handed. Let's see how many will be maybe not right-handed, because you can only be right or left-handed, and those who don't play soccer. Because in the class of 30, right-handed will be 5, and they play soccer, right? But some of them, they don't all play soccer. It's only 2 who will be right-handed and not play soccer. They're only right-handed. Right. So how would we figure out this one? Well, I'm going to work it out by saying it's 30 minus. So now what I want to do, let me do it here. 30 minus. So now I want to exclude. I want to take away the 2, the 3, the 9. Because I need to see how many pupils belong here who are not right-handed and they also don't play soccer. So this will be 30 minus 14, and that gives me 16. So the 16 will go in there. So that's how you draw your Venn diagram. Now that we have filled it in, we're going to answer the questions. Are the events, if you look at the first one, are the events playing soccer and right-handed? Are they mutually exclusive? So mutually exclusive means the one has nothing to do with the other one. So for example, the probability of play soccer or right-handed, if it's mutually exclusive, it means it will be equal to those playing soccer. Well, let's start off with play soccer, everyone playing soccer, plus everyone that's right-handed. So that's when it will be mutually exclusive, right-handed. It means nothing will overlap. So play soccer or right-handed will be, you don't have to write all of this in the exam, I'm just explaining. It will be the 2 plus 3 plus 9. Playing soccer or right-handed, so you add all of that. So that will give me, and it's of course over 30. So this will give me 14 over 30. And let's see if that's equal to the right side. If I take everyone playing soccer, that's 5 over 30. And everyone that's right-handed will be 12 over 30. And that gives me 17 over 30. So because the left side's not equal to the right side, it will be not mutually exclusive. Well, you can use this explanation, or you can basically just say, give a reason. Are the events? No, events are not mutually exclusive, And I'm just going to say, because the probability of being right-handed and play soccer, this is the shortest explanation, and play soccer is not equal to 0. So if this was 0, meaning if it was two separate categories, the right-handed and playing soccer, and there was nothing that overlaps, then it would have been mutually exclusive. But because there's something that overlaps, it's mutually not exclusive, right? So this one is mutually not exclusive. So mutually not exclusive, the formula looks like this. So this is mutually exclusive, and mutually not exclusive will look like this. Play soccer or right-handed will be equal to everyone that plays soccer plus everyone that's right-handed minus the overlapping, minus the probability of the right-handed and those playing soccer, right? So that's the other formula. Let's look at the next question. It says here, how many of the learners in this class are left-handed and they also don't play soccer? So it's not, just anywhere, it's actually going to be in the class. How many learners in the class are left-handed? Well, we already know those in the class that are right-handed will be 5. So if you're not right-handed, you will be left-handed. So what do you think about this? These pupils that remain here, will not be right-handed because they haven't been included here. And they will also not play soccer because those in the Venn diagram who play soccer, they are 12. So therefore, the learners that are left-handed and do not play soccer is going to be the 16. Okay, they don't ask the probability. They ask how many. They're not asking probability, so we just say 16 learners. If they said what's the probability of being left-handed and not playing soccer, then you would have said the probability would have been 16 over 30. But now they just ask how many learners. So it will be 16 learners. Now they ask us, determine the probability that a learner is left-hand and plays soccer. So you understand the difference between the between the two questions. How many learners are left-handed and do not play soccer? 16. But now they say determine the probability that a learner is left-handed and plays soccer. So now it's probability, but now the question is not the same as the previous one because they say he's left-handed, but he also plays soccer. So let's first see how many learners play soccer. So let's think it out. Plays soccer, there's 12. Plays soccer would be 12 learners. But then they say the probability that a learner is left-handed and plays soccer. So how many are right-handed and play soccer? 3. So 3 learners. So we're going to minus the 3 learners are right-handed, right? So there's your 3 learners that are right-handed and they play soccer. So therefore, it will be 9 learners will be left-handed then. And they will still play soccer and play soccer. Again, for the answer, you don't have to write all of this. It's just me explaining how to get to the answer. But because they said probability, the probability, so this is how you write your answer. Probability of left-handed and play soccer would then be 9. And because it's probability, you write it over the total. Simplify this, so it will be 3 over 10. So you can either write the answer as 3 over 10, or you can write the answer as a decimal. You can also write the answer as a percentage. I'm also now going to look at a question from the Gauteng paper from November 2017. So before we're going to look at the questions, I want to discuss something. I want to discuss complementary events. It's something that you will see in grade 10 and in grade 11. So 2 events are said to be complementary when one event occur, okay, it's my spelling mistake there, occur, there must be not spelling mistake, there must be a space there. When one event occurs, if and only if the other one does not. So it means they can't occur simultaneously. It's like you are swimming, those pupils who are busy swimming, and those pupils in the library. So you can't swim and be in the library. So what they do here is they give an example. For example, rolling a 5 or greater and rolling a 4 or less on a die are complementary events because a roll is 5 or greater if and only if it's not 4 or less. So I just Googled complementary and this is what came up. So let me just explain. If you think of a die, you can either throw a 1, a 2, a 3, a 4, a 5, a 6. I just want to write it twice to explain 2, 3, 4, 5, 6. So the example says, rolling a 5 or greater. So let's say the chances that you will roll a 5 or maybe a 6 can only happen if you don't throw a 4 or anything smaller than that. But they can say anything here. It's just playing with words. It's just showing that it can't happen together. So they can also have said, for example, to roll a 6. To roll a 6 will be only possible if you don't roll a 5 or less. That's obvious, isn't it? It's just to explain what it means. Here's another explanation. In probability theory, the complement of any event A is the event not A. The complement of an event A means it's not that event, it's the other one. So complement means it's not that one. Not that one, it's the other one. For example, the event that A does not occur, the event A and its complement, meaning it's not A, are mutually exclusive. Exclusive means the one has nothing to do with the other one, and exhaustive. It's a nice description, isn't it? It's exhaustive, meaning there's nothing that remains. You are done. There's nothing, no energy. Let me explain to you what they mean. Let's say there's 10 pupils who take maths in the school, in your class, there's 10. Now, let's say 3 take maths, pure maths, and 7 take maths lit. So you can't take both. So we can write it like this. The probability of the complement of A is 7. So the complement, that means complement. It means it's not in A. So if you see anything like this, it means not in A. So not in A means in B. So instead of writing the probability of not in A, you could have written the probability of B, therefore, is 7. They could have said the complement of B, what is not in B, is 3. So what is not in B means it's therefore going to be in A. So therefore A will be 3. And it's mutually exclusive, meaning there's nothing that overlaps between the two. There's no and. It's not going to overlap. There's nothing there. So it means you can also say the probability of A and B will be equal to 0. There's nothing that overlaps, right? So now that we have a little bit of background, let's answer these questions now. The first one, it says, 2 events A and B are complementary. So if you see a question like that where they say it's complementary, imagine then this. The events A, so this one is going to be A, and this one is B. They are complementary and they make up the entire sample space. What they mean by that, this total block, the Venn diagram block, would be the sample space. If they take up the entire sample space, it means there's nothing here, there's nothing outside. So let's look at the information. They say here the complement of A is 0,35. Not in A is 0,35. And so let's see. Let's make this one the pupils taking maths. So let's make this one maths. So because it's 35, 0.35, let's just say it's 35 over 100. So I'm just going to say, because with complementary, it must always add up to 1. The total must always be 1, or like 100%. So if this is maths, let's say it's then going to be 35 pupils take maths. And therefore, if it's not in A, it will be in B. So how can you work it out? You can say 1 minus 0,35, and that's going to give you 0,65. So therefore, let's make this one maths lit. So this one will be 0.65, right? But this is not the answer for the first one. They say here, complete the following statement. The probability of A plus the probability of B must be equal to 1, because it will always add up to 100%. Write down the value of A and B. Now, because it's complementary, there's nothing that overlaps. So when it's like this part will be A and B. So write down this value for A and B. The value of A and B is equal to 0 because there's nothing. Then they say, write down the value of B, the probability of B. So the probability of B is going to be, so you have to work with what was given. So B is going to be literally that which is not in A. And not in A is 0,35. Let's look at this Venn diagram. This is the last question for this session. A survey was conducted among 150 learners. So it means we sit there with a sample space of 150. To establish how many of them own the following devices, a smartphone or a tablet. Then they figured out, so before you just randomly write down all the answers, read everything carefully. So I'm going to work here with my smartphone and I'm going to work here with my tablet. 8 learners did not own either a smartphone or a tablet. I'm safe to put it there. They didn't own any of them. 20 learners owned both a smartphone and a tablet, so I'm safe to put it there. 48 learners owned a tablet. So now it's very important that if they give you the total, that you write the total there. You're not going to put it inside the circle because that there would mean 48 only have a tablet, and that's not correct because some of them also own a smartphone. So I'm going to write the 48. Yeah, you see. So if they give you the big total, 48 learners own a tablet, you write it there. X learners owned a smartphone. A smartphone will be X. So that's how you start off with your Venn diagram. Now to fill in these, how many learners will only have a tablet or only have a smartphone will be the whole circle. The whole circle is 48 minus those who also own smartphones. So you can't count people twice. It's impossible. So then this one will just be 28. So 28 will only own a tablet. What will this one be? X minus 20, because we have no idea what is the value of X. So that's how you will represent your Venn diagram. So that would be the answer for this one. Now for the next question, they say how many learners owned only a smartphone? So only a smartphone, you can't write the answer as x minus 20 because you have no idea what is x. But that means we must first figure out x. So this would be only a smartphone will be the x minus 20. So in order to figure out x, we're going to write down x minus 20. Then we're going to add the 20. So literally you add everything inside the two circles plus whatever's outside the two circles. Plus 48. Oh, I can just add my 28, because that's what's inside there, plus 28 plus 8. And all of that will add up to 150. So quickly go and work it out. You must stay in practice to work it out yourselves. Grab the calculator. If you work out all of this, minus 20 and plus 20 already falls away. It's going to be, if you just work it out and you say 150 minus that, so this would be x plus 36 equal to 150. So it's going to be 150 minus 36, and that gives you 114. Right. So how many learners only owned a smartphone? So therefore, only a smartphone will be x minus 20. That's going to be 114 minus 20, and that gives me 94. Right, so let's look at the last two questions here. Calculate the probability. So now it must be the amount divided by the total that a learner, and I just want to show you here with the previous one, they said here how many learners. So that's why I only wrote 94 and I didn't write 94 divided by 150. But now they say probability, so we must work with the total. The probability that a learner selected would own only a smartphone. So only a smartphone will be 94. The probability of only a smartphone is going to be the 94 over the total, and that gives me 0.63. How many learners owned at the most one type? So here I want to explain something to you. If I say you must own at least, let's do it here, at least you must have at least 2 pairs of shoes. You must have at least 2 pairs of shoes. One to go to school with and one to go out with. But many of you might have some sport shoes as well. So although you need at least, it means you can have more. You can have more. Right? You with me? So how many pupils will have at least a smartphone? Would be 94, but they can have more. So they can have 94, plus they can have 20. It could also be the 20 if they own both, or it could be the 28. And we're not going to include then the 8, because 8 means you have none, not one of the two. But you must have at least, so it means we are going to look at more. What if they ask you at the most, you must have one type? So let's understand that. You must have one. Have one. So you must have at the most, or let's think of people who don't have anything. So at the most, they will have one. At the most, think of poor people. At the most, they will have one pair of shoes, but they might have none, but they might have none. So in some of the poor schools, we will say that at the most, they will have one pair of electronic device. At the most. They won't have two. They will have at the most one type. But it could be that they also have none. So let's see, how would we fill that in? The probability of a smartphone or a tablet. They can maybe at the most have one of them, or they might have none. So that means it could be the 94. It's probability, so we add it over the total. Or it could be the 28. They might have the chances of only having one. So maybe only a smartphone, or maybe only a tablet. The tablet there was 48. But this was the total. So again, we just look at the 94 and the 28, because otherwise we count the 20 both, twice. But they might have none, so we have to include the 8. That will give you 130. Simplified, so it will be 13. And you can also write it as a decimal if you want to. Okay, I hope you understand your probability slightly better.